Okay, so today we're looking at separable differential equations, and they're going to be of the form dy by dx equals f of x times by g of y. So two functions there. All right, so what on earth does this mean, and what does separable mean? So if we're given a function dy by dx equals f of x and g of y, so we've got both x and y appearing on our right-hand side. What we can do is we can separate this function. So we can bring the g of y to the other side. So we get 1 over g of y dy by dx equals f of x. All right. Next, by the chain rule, we can rearrange this to be 1 over g of y dy equals f of x dx. Now what we see is we've got all the y's on the left-hand side, all the x's on the right-hand side, and we can integrate both sides to work out the answer. And that's basically separable differential equations. So we'll jump straight into an example. We want to solve the equation dy by dx equals xy. What we want to do first is we want to get all the y's on the left-hand side. So divide by y, we get 1 over y dy, and bring the x to the other side, equals x dx, and we want to integrate both of those. Now if we integrate the left-hand side, we get ln natural log of y equals half x squared, and the only other thing we've got to do is plus c. Now what you are often asked to do, well, what we have to do is we have to get y by itself, because we generally write functions as y equals. So if I put the right hand side to the power of, or e to the power of ln y, and do that to the other side as well, half x squared plus c. These are opposite operations, so they cancel, and we're left with y equals e to the power of half x squared times by e to the power of c. C is just a constant. And we can write that as y equals e to the power of c, we can just call that a, it's just another constant, e to the power of half x squared. All right, and we've solved that differential equation. So let's have another go. So we've got dy by dx equals y squared plus 1 over 2x, and we know that y equals, when y equals 1, sorry, y of 1, so when we sub in 1 for the x, we get 1 as our answer. So again, let's rearrange. So bring the y's to the left-hand side. I get 1 over y squared plus 1 dy equals 1 over 2x dx. So if we remember our rules from our last topic, when we've got 1 over y squared plus 1, and we're integrating to dy, we're going to get arc tan of y equals half natural log of x plus c. All right. Next, we want to get y by itself. The opposite of arctan is to take tan. So if we take tan, we'll be left with a y. Tan of half natural log of x plus c. Now we've got to jump back up here. So when we put in 1 for our x, the function is going to equal 1. So we get 1 equals the tangent of half natural log of 1 plus c. Now that's really interesting because the natural log of 1 is 0. So we get 1 equals tan of 0 plus c. So tan, so this part here goes away. We're just left with tan of c. Now, the only time this is true, so 1 equals tan of c, is for, therefore, c equals pi on 4. All right, so that's allowed us to work out c. So therefore, the particular solution for this is y equals tan 1/2 the natural log of x plus pi over 4. All right, and that's how we solve differential equations that are separable.